This video is all about the distributive property. You're going to need it to solve more complicated equations. The distributive property is all about distributing a piece to everything that's inside the parentheses. Distributive property, I think of the word distribute. If you distribute gifts, you're giving out gifts. So you distribute it out to each person. So in this case, we'll look at the example of taking the 4 and distributing it or giving it out to the 2 and to the 3. You have to give it to every single piece inside of that set of parentheses. That results in 8 plus 12, which is going to give us 20. These first two examples are supposed to prove to you that this method works. And to do so, I'm going to show you an alternative method that works for just this example. If you take 2 and 3, those are like terms, you can go ahead and combine them and you get 5, and you multiply 4 times 5, you get 20. So this is basically a method that you already know, is you can combine the 2 and the 3 using like terms and then multiply, and you get 20. And you'll see that if you use the distributive property, you'll get the same answer as when you do it this other way that I showed you. So let's look at the bottom example. Using the distributive property, we would take the 7 and we'd multiply it by the x. And we'd take the 7 and we'd multiply it by the 2x. And we get 7x plus 14x, which is 21x. The way you already know how to do it is to collect like terms. 1x plus 2x is 3x, and then 7 times 3x is 21x. So hopefully you feel like you understand that this method will work every time. And we're going to go through a series of examples. In the first example, we have -7 multiplied by the quantity x plus 4. These are not like terms, so we can't combine them. We have to use the distributive property. And I'm going to put a blank plus a blank. You're going to have the number of blanks will be equal to how many are in this set of parentheses. There's 2 terms in this set of parentheses, so we're going to have 2 blanks. You always take what's on the outside and you multiply it by the first value, x, and then we take the -7 and we multiply it by the second value, which is 4, and then we simplify and we get -7x plus a -28. You could write these in different ways. I could have also written this as -7x minus 28. But we cannot combine the -7x and the -28, so that's our final answer. It's as simple as it gets. B, you take the 4 and you multiply it by the 3x, and then you take the 4 and you multiply it by the -1. 4 times 3x, we get 12x. 4 times the -1, you get -4. So we have 12x minus 4. Letter C. Once again, you have your 2 blanks. I take the -8 and I multiply it by the -2x. What's key here is to make sure that you always include the signs in front of the terms, or in front of the values. Then I take the -8 and I also need to distribute it to the -3. So -8 multiplied by the -3. -8 times -2x, we get 16x. -8 times -3, we get -24. And these are not like terms, so that's the final answer. Letter D. The 5 we distribute to the -2x. The 5 we also distribute to the 8. 5 times the -2x, we get -10x. And 5 times 8, we get 40. Letter E. This might be the point where you go ahead and you pause the video and you see if you can fill this in on your own. Hopefully you're starting to get the idea of how this works. And then you can watch what I do to see if you did it right afterwards. I took the 6 and distributed it to the negative x for a negative 6x. I took the 6 and distributed it to the negative 3 to get a negative 18. I could have also ordered it as negative 18 minus 6x. So these are all acceptable answers, all three of those. Letter F. Now you'll see we have 3 pieces inside of the set of parentheses, so I'm going to go ahead and draw 1, 2, 3 blanks. And in the first set of parentheses, I'm going to multiply negative 4 by the first term, 3x. In the second set of parentheses, I'm going to take the negative 4 and I'm going to multiply it by the positive 2y. In the third set of parentheses, I'm going to take the negative 4 and multiply it by the negative 7. So it's the same process. You're making sure that everything is distributed to each piece inside of the parentheses. Negative 4 times 3x, we get negative 12x. Negative 4 times 2y is negative 8y. And negative 4 times negative 7 is 28. Once again, I'm trying to show you that there are different ways to write this. You could also switch the order. Let me switch the order one time. So those answers are all the same thing, just written slightly differently. Letter G. It's a similar example. The 2 is distributed to the negative 4y. The 2 is distributed to the 6. And finally, the 2 is distributed to the negative 3x. We get negative 8y plus 12 plus negative 6x. Letter H. Two blanks here. Now you'll notice it's a little bit more complex because I have a negative 6 and an x. So I'm going to multiply that whole piece, negative 6x, by the negative 3x. It's the same process. Then I take the entire negative 6x and I multiply it by the positive 2. And we get a result of 18x squared. If you need to reorder it, you can. So it's negative 6 times negative 3, and then x times x. Remember, when the bases are the same and you're multiplying, you add them up. You add those exponents. So your exponent rules apply when you're multiplying or dividing. Negative 6x times 2, we get negative 12x. And these are not like terms because one has a power of 2 and one has a power of 1. So the final answer is 18x squared minus 12x. And you'll see I just combined the positive and the negative and made a subtraction symbol. Letter I. Negative 2x is being multiplied by the 4x. Negative 2x also needs to be multiplied by the negative 5. You're distributing what's on the outside to everything on the inside. We get negative 8x squared plus positive 10x. Final answer. In general, when you order terms, you want to choose a variable that you're ordering by, and then you look at the power and you order according to the power. You go from greatest to least. So we start with a power of 2 and then we ended with a power of 1. So in general, that's how you want to order your terms. Letter J. The reason I gave this example is because I wanted you to remember that when you have something like negative x, the coefficient on the x is a negative 1. And it's really unnecessary to write the 1, so that's why you normally see negative x. And then the same is true over here when we take negative x and we multiply it by negative x. So it's really negative 1x times negative 1x. Well, negative 1 times 9 is negative 9. So you have a negative 9x. And then a negative 1 times a negative 1 is a positive 1. Positive 1x squared. And once again, I'm going to leave off that coefficient of 1 because it's unnecessary. So the answer is negative 9x plus x squared. Now thinking about what I just said in the last example, if you ordered it according to the variable x, the proper way to order it would be x squared minus 9x, so that it goes 2 and then 1. Letter K. I need 1, 2, 3 blanks. And then I take the negative x and I multiply it by the first quantity, 3x. Then I take the negative x and multiply it by the 2y. Then I take the negative x and I multiply it by negative 4x to the power of 5. Negative x times 3x gives me negative 3x squared because you multiply the numbers. 3 times negative 1 is negative 3. Then you multiply the variables because they have the same base and you get x squared. Then negative x times 2y, I get negative 2xy. I put the x in front because I'm going to order it according to the x variable instead of the y variable, so that's why I chose to put that first. This would also be a place where you could write negative 2yx. They're the same thing because of the commutative property of multiplication. In the next example, I get positive 4x to the power of 6 because I take the negative 1, multiply by the negative 4 to get 4. Then x times x to the 5th gives us x to the 6th. And then from here, let's go ahead and order it. 4x to the 6th. And after that would be negative 3x squared. And then after that would be negative 2xy. And if you wanted, you could have just made this a subtraction symbol. So it'd be 4x to the power of 6 minus 3x squared minus 2xy. Letter L. 3 blanks again. Take the 5x and multiply it by the 2x squared. Then you take the 5x and you distribute it to the 7m. And then finally you take the 5x and you distribute it to the 12. 5x times 2x squared, we get 10x to the 3rd. Then 7 times 5 is 35. And it could be xm or mx. And then 5 times 12, we get 60. And then you have an x on the end. And if I were to order it according to the x's, this would be acceptable, or I could have put 6x before the 35xm because they both have a power of 1 on the x variable.